Hey guys, Mike here from Fortinet Guru and Packet Llama. Today's video, I'm specifically going to take a FortiWi-Fi 61E running FortiOS 7.4.2, and I'm going to go through a basic configuration for you. Please note this video is specifically for a standalone FortiWi-Fi 61E. This device will not be managing any Forti switches or other Forti APs. We'll have more in-depth videos for the full stack, much like we did on our old 60F one. Before we get started though, do me a favor. If you haven't already subscribed to the channel, go ahead and hit the subscribe button. And if you're feeling frisky, head over to Packet Llama, which is going to be in the description. It's another one of our channels. It's a brand new channel. And go ahead and hit subscribe there as well. It helps us grow and it's going to help us get to where we need to be. We have our FortiWi-Fi 61E. We need to run through some things. There's a lot of stuff that you need to take into consideration when you're planning out your deployment. This deployment is going to assume that you're a small office, home office, maybe a branch or something like that, where a FortiWi-Fi makes the most sense for you. So what does that mean? That means you're probably not going to have a bunch of switches. If you do, they're probably going to be unmanaged. You're certainly not going to have a lot of VLANs or anything like that. So first things first, we need to jump over to our interfaces. Why is this important? A FortiGate is a zone-based firewall that will not allow traffic to traverse from one interface to another without a policy. What does that mean? That means if you have an internal network, this is your local network, your standard 192.168. whatever, or whatever IP you decide to give it. If you have an internal network and it wants to go out to the internet, which is this WAN interface, it's not going to do so without a policy. That's the same for logical interfaces like IPsec tunnels, VLANs, things of that nature. So just always keep that in the front of your mind. If I expect a packet to go from interface A to interface B, I damn sure better have a policy or else I'm going to have a lot of trouble. If you've seen any of my previous videos, you know I am a huge fan of zones. In my previous videos, I would say create an inside zone and an outside zone and utilize that for the grouping of interfaces. A zone is basically a logical grouping of interfaces that are a member of it so that you don't have to duplicate policies. So what I'm going to do is I'm going to create my inside zone. And this inside zone is going to keep my internal network. Okay. That's going to be the network that's inside to my environment. Now, you may have noticed previously I said, I used to create an inside zone and an outside zone, a standard system zone. I don't do that anymore. I create standard zones for internal interfaces and things like that. But I have started using SD-WAN zones for anything that could be external facing. And there's a pretty good reason why. Obviously, in today's day and age, the opportunity for an individual to have multiple internet connections is high. And we like to have that granularity where we can actually pick and choose where we want packets to go based on a plethora of criteria. Maybe we have voice traffic. We want it to go over our fiber line because that fiber line is significantly lower latency and lower jitter. Or maybe we have, just some raw downloads that we want to go over the standard broadband coax line. There's a lot of raw bandwidth there, not as good on the quality of latency and jitter, but it would meet the needs and the use case, right? There's really no reason not to use SD-WAN zones, even if you have a single interface today, because in the future you will eventually have a secondary one or multiple paths to the same destination. And that's really where that comes in. So we are going to create an SD-WAN zone. I'm going to call this SD-WAN zone outside because I am very predictable, right? Very predictable. I have a very specific approach that I like to take things. If you are inside to my firewall, you're in the inside zone. If you're outside, you're on the outside. So you notice we did this under the SD-WAN area. I created the inside zone within the interfaces area. So I went over to SD-WAN and I created an outside SD-WAN zone. Previously, I wouldn't necessarily utilize SD-WAN zones because SD-WAN wasn't as mature on Fortinet equipment, and I was still stuck in the old school way of, let's use link monitors and the manual way of doing things. I have since matured as an engineer. Not to mention Fortinet's kind of matured as a product when it comes to SD-WAN. So now I created my zone that'll be used for my destination and a lot of my policies. But first I have to add an interface to that SD-WAN zone. So we'll create a new member. And as long as your interface is not referenced by another thing like a policy or something like that, you can choose it on the interface list. As you can see, WAN 1 is not referenced currently by anything else. Now, if you've ever played with FortiWall and things like that, you may remember that when you're configuring an interface, it's fairly common for you to have to define the gateway of said interface within the FortiWall interface configuration. Used to on Fortinet, you would just do static routes separately. But since this is SD-WAN, it uses a lot of the same kind of mindset. Now, my WAN 1 interface is not a static IP. It is DHCP, so the gateway will be dynamic, and it'll use the gateway that it pulls from DHCP. If this were a static IP, let's say it's a true public-facing internet circuit, what you would do here is you would define what the default gateway for your static IP would be. So, cost and priority, I'm going to leave these where they are by default. Cost has to do with how expensive the link is considered, and priority has to do with whether or not you want that link to be used in the case that cost is the same across multiple members. And they give you a little tool tip here that kind of gives you a deep dive into how it works. But basically, the priority value will be used in static routes that are created for the SD member interface. And basically, the lower this value, the more preferred that link will be. If you were doing a standard interface configuration and you had multiple paths out to the internet, you would have multiple default routes. You may give them all the cost of 0 or the administrative distance of 10, but the one that you want to be the preferred outbound destination traffic would have a lower priority, basically. I went into a little bit deeper of the who, what's, and whys on the actual member add portion because there's very subtle variables that you see in there are going to pay dividends in the future when you're doing your SLAs. So we come over here to performance SLAs. We have a whole bunch of them out the gate. I'm going to go ahead and delete these. I never use any of those. Create new. I'm going to go to a DNS protocol and I'm just going to call it Google. Now this already existed before, but like I said, I'm OCD. And basically what this SD-WAN SLA is going to do is it's going to say, all my SD-WAN members need to be able to access Google via DNS, not ping DNS. And as you can see, my WAN 1 circuit is able to hit Google DNS at roughly 17 milliseconds with 0.56 jitter, which is good because it's going from copper out to a fiber connection. Now, if you had multiple member interfaces, you would create rules saying, all traffic use this link unless, or use both links, but prefer the link that has the lowest cost as long as it's within SLA. We don't have multiple interfaces here, so I'm going to skip over that specific portion. We'll have a video specific to SD-WAN in the future using my primary firewall. But just know that out the gate, it's going to send it out. We only have a single interface, so it's not really as aware. The only reason we're configuring this in an SD-WAN zone is to be more future-proof for when new circuits come in, etc. So now we have our SD-WAN. We have our inside zone. When you originally spin up your box, this internal hardware switch will automatically be IP'd as 192.168.1.99. Obviously, the default password and username are admin with no password, and it makes you change those upon login. Now, as you can see, I am actually connected to it via my WAN 1 interface because this is a FortiGate that's behind my house FortiGate. So I can give this guy whatever IP scheme I desire. Now this is going to be up to you. This is personal preference. You can use whatever you want here. Just know that you need to use what we call RFC 1918 space, private IP space. And if you don't know what that is, you can Google it. But basically it's like 192.168.0.0 through .255.255 or something like that. 10.0.0.0 to 10.255.255.255, and then 172.16.0.0 to 172.31.255.255. Google it. It'll be much easier than you trying to remember my southern accent, rambling that off. But for the sake of this, I'm just going to make it be 10.250.100.1. Now, this is going to be the inside interface of my firewall. That means that that's going to be my default gateway for anything on this network. We're going to enable DHCP. And by default, the FortiGate is going to want to use that entire range. If you have specific devices that you want to be a specific IP, there's a couple different things you can do. You can statically set those devices on the network and make sure that your DHCP range will not issue out that IP, meaning you can make the range smaller so that you have a gap that won't overlap. Or you can use DHCP reservations and just go with it there. For the sake of this, I don't have any of those needs, so I'm just going to turn it loose and let it be here. I like to enable device detection because I want to see and understand as much about the networks that are, or as much about the devices that are behind my network as possible. Okay, so that's my inside interface. This is my inside zone that references my internal hardware switch, which are ports 1 through 7 on the FortiGate. Remember, we're not using FortiSwitches on this, so the FortiLink interface isn't going to be used. Now, this is a 61E, which means it did not come with the A, B ports that you would normally see on a FortiGate these days. So that's actually an aggregate interface that doesn't have any members. If we were to use FortiSwitches, we would tear some ports off of the internal hardware switch, associate them with that aggregate interface, and that would send us on our way. But that's for another video. So we have our interfaces, we have our SD-WAN zone created, our member associated with it. Now we need a static route. Why do you need a static route? Well, WAN 1 knows where its default gateway is, but it's now an SD-WAN member, so you need to have a static route saying, hey, if you don't know where to go, like if it's not a connected route or there's not a specific static defined, you need to use my good old handy dandy outside zone because that's my SD-WAN interface. And that'll enable packets that come in through the internal interface to traverse out to the internet as long as policy exists. So that brings us to the next wave. We have our inside interface for our simple network. We have our outside interface configured, the zones associated as such. Now we need to build policy. Now this is where it gets fun. You bought a Fortinet FortiGate. What's that mean? That means you're not just running source, destination, port and protocol style firewall. You have layer 7 capability. You are a next-gen firewall that can make decisions based on a plethora of things. So what we want to do, and I like to configure brand new firewalls for operation. I'm a cybersecurity expert, but I like to configure my devices for operation. Seems like an oxymoron, right? It's cyber, you need to lock it down as much as possible. I'm also a business owner, though, and I understand that things need to function or my business does not make money. So what I'll do is I'll configure some basic security profiles that'll block the big nasties that I absolutely want gone, but provides me monitoring so I can be aware of what's on my network as much as possible. And then from that, packets are passing, only the really known uglies are getting blocked, and I can use my FortiAnalyzer or my logging tool to observe that and slowly tighten down the vice grip on my security. Ultimately, we want it to be deny by default, allow by exception, but that's not very translatable to the real world unless it's a greenfield environment. And what I mean by a greenfield environment means is you don't have anything up and running yet. You could go gangster right out the gate. You don't really get that a lot. So under security profiles, this is where you actually configure your layer 7 UTM, your unified threat management profiles. It gives you a list of defaults out the gate. Now you're going to see some alerts on some of these. This FortiGate is not licensed, which means if I enact this, it won't work the way we expect it to. It is what it is. I'm not going to buy a license for a test FortiGate that I use specifically for videos. So, default, I do not like to use default profiles. The reason why I don't like to use default profiles is firmware updates will change those back from time to time. A really, really big instance of that is I had a client that used the default LLDP profile on FortiSwitch management, and firmware updates reset the auto ISL option on that back to disable, and it broke all their FortiSwitches. We had to manually go through and fix all that. So I just like to take the profile I want and clone it. Now this is our AV profile. We're going to name it AV Web. You want this to be descriptive. If you have ever seen one of my old videos, you will know I used to name everything base. If you're ever troubleshooting an issue and all of your security profiles have the same damn name, you're going to run into problems. I have since learned. So obviously, we're always maturing as engineers, right? I make it descriptive. This is the AV profile for web traffic. If you come in here and look, you can see it's going to block things based on the AV scan. These are the ports or the protocols that it's going to actually scan against. It's automatically going to treat Windows executables and email as malicious. If you have a FortiSandbox, you can send things up to get it inspected. FortiSandbox will do some detonation for you and send you on your way. And then there's some couple other checkboxes for various things. Like you can do quarantine, which has to do with like outbreak protection and all that. Obviously, I'm not licensed, so I can't use half these things. And then, of course, you could do external malware block list. Thanks to the Fortinet API, you can do a whole lot of cool things that can basically automate a lot of what we do, right? So we're going to leave AV Web as is. For web filtering, remember, we want to see what's out there, right? So we're going to do web internet. I'm going to use the categories. I like to set everything to monitor. Why? I set everything to monitor because monitor will allow the traffic, but make a log of it so you can run reports. You can see what folks are going to. Now, obviously, we want to have some say in what they're doing. Maybe we don't want them to do remote access, so we'll block that category. We come up here to, the heavy hitters of security risks. So we'll block malicious phishing and spam URLs. We don't really care if they can't get there. And if there's a site that is erroneously categorized as such, we deal with that later. And then we will block porn, because why not? Typical things like that. These are you don't care if it blocks because it's most likely not going to stop work function. Unless, of course, you run a porn company or something like that. Now you come down here and you have a couple other options. These are for later because you can do custom URL filters, whitelist, blacklist, based on what you want to do. You can actually do content based on specific patterns and such. These are two checkboxes that I absolutely recommend you check, both on web filtering and DNS filtering, unless you are a military installation or a medical installation that absolutely does not want a packet to pass unless it's been approved. Allow websites when a rating error occurs. If you've run Fortinet gear for any length of time, they're not infallible. Their servers will be slow to respond from time to time or experience some type of congestion or something. And what that checkbox does is it says if the FortiGate doesn't have the category of this saved, it will reach out to FortiGuard and say, hey, this is michael.com. What is it? If it can't get a response from FortiGuard and that box is not checked, it won't pass the packet. It'll deny it as unrated. And then, of course, rate URLs by domain and IP address. Why do I check this one? There's a lot of virtual hosts out there that have thousands of sites on a specific box. Now, those thousands of sites may be running various versions of WordPress or Joomla or whatever CRMs or CMSs or, anything out there, right? They're not all made equal. And WordPress, I certainly fight with it all the time. They're likely to get hacked. Now, the domain may be clean. It may very well be clean, but the IP associated with that domain may not be, because another host that's on that same IP or another website that's on that same IP may be compromised, and on the back end, it's able to do some things. So I like to rate URLs by both domain and IP address. It's a little bit higher quality. It gives me a little bit more warm and fuzzies, if you will. So that's our web internet. And just for this, I'm gonna rename this one from that to AV. Now, DNS filtering. So for DNS filtering, we're just going to click new. I'm going to name this DNS Internet. And of course, we're going to have this thing monitor everything as well. I don't usually block most things via DNS. I like to let web filtering block it. Is it a potential risk? Yes. So be aware that you might want to block here as well. So like, for instance, malicious spam and phishing, we can block these guys. But DNS is just going to redirect them to a portal page, which is going to give you an SSL error until you install certificates and things like that. But that's just how it works. And as mentioned, log all DNS requests when a rating error occurs. That way we have an audit trail. And then to log all DNS queries and responses, we want to be able to see what's going on. And if FortiGuard is down, we want it to be able to traverse. Now, application control. This is the heavy hitter. This is the main reason you bought the FortiGate, man. You want to be able to see the applications that are using your network, right? And just like before, I'm going to set all these guys to allow for right now. The only thing I care about is what's on my network. And then I can make educated decisions about what I should or should not lock down. This is going to be heavily dependent on use case. So, obviously, if you are a hospital or a bank or a federal government or something like that, right out the gate, you're going to have some level of blocks. Maybe you block remote access, peer-to-peer, things like that. But it's use case specific on where you're deploying it. If you're at your house, allow it all. Watch what's taking place on your network and then block as you see stuff that you may or may not wish to do. What I usually do is I monitor all, I run a weekly report, and I will slowly chip away at it and block things that I know should not be on my network. It works. It works. It is. It's not denied by default right out the gate, but you eventually progress to that point. So I have all of these guys set to monitor. Go, okay, that's my internet application profile. Now we need to build out policy. This is what's actually going to let the traffic go out to the internet or cross interfaces like we mentioned. So we go to create new. We want the packet to pass. This is a new deployment. We want to get it in and get it operational and then tighten security down. So we're going to call this temp allow. Oh, it's a catch-all policy. Inside to outside, all sources to all destinations for all services. This is about as promiscuous of a policy as you can have. And most other vendors come with this policy right out the box. Actually, Fortinet does as well. This device has been factory reset and then manually deleted for me. But right out the gate, it has a LAN to WAN policy or an internal to WAN policy that allows all traffic. So, because they want you to be able to get up operational as quickly as possible as well. Now we're going to come through here and we are going to apply the sensors that we have. Now remember, this device does not have a license. And in newer versions of code, Fortinet lets you know there's no active license here. It's really, really good because these things are only as strong as the license that they have. So, SSL inspection. There are three major tiers of it. There's no inspection, meaning you don't look at the cert at all, which costs you a lot of visibility. There's cert inspection, which means the FortiGate is going to look at the certificate header and say, yeah, it says it's Facebook. We're going to assume it's Facebook, but I can't tell you any of the stuff that's taking place within it because it's only checking the header. It's not going to check the payload. And then you have deep inspection. If you're watching this video, you are not ready for deep inspection. That is a lift in and of itself. We will have a video dedicated specifically to that. So this is our catch-all policy. This policy will allow traffic out to the internet. And as you can see, it's from inside to outside, all sources to all destinations, meaning anything that's within that inside zone can go to anything on the internet for any service all the time. The schedule is always. We're going to accept it, and we're going to NAT that traffic. What is NAT? NAT is the translation of IP space into another. That's really what it is. This is source NAT. So this is going to convert the 10.250. whatever to the outside interface of the FortiGate. Now, normally your firewall will have a public IP address on it because it's connected directly to your modem. And what that does is that enables all of your devices to present themselves as that public IP. Why is this important? One, that's a way to mask the devices behind a single IP. Security through obscurity on some level. But two, it enables the internet services to actually come back in and find its way back to you. Because all of that RFC 1918 space, it's private space. It's not publicly routable. So it's a standard policy. And here's all of our security profiles. Now, I like to log all because this is going to be brand new. But this gets you operational. Now, what do you do from here? Well, you want to build out specific policies to allow the traffic you wish to allow. You want to deny by default, allow by exception. So if you have a domain controller or DNS server that lives in your environment, you would build out a policy above this that says, insert above DNS out. And your source would be your DNS server. So, 1.2.3.4/32. Let's say that's the IP address of your server. This is just an example. That is not a real IP. And you want your stuff to be descriptive. Internal DNS server, 1.2.3.4. Yes, I wish to select my new entry. Fortinet's done a really good job of taking the GUI and doing some assumptions to help you speed along your process. My destination, maybe my internal DNS servers should only be able to use Google. So Google 1 is 8.8.8.8. And then Google 2 is 8.8.4.4. Yes. And the service will be DNS. And then we will do our DNS filter on that. Log all sessions. Okay. So what's the significance of this? Firewall policies read top to bottom based on matching. So what that means is my internal DNS server, any traffic coming from my internal DNS server trying to go to Google, which should be the only DNS that I wish to allow on my network, right? We'll allow, and we'll log it. And then, we'll build another policy for web traffic, another policy for email. Maybe we build some custom internet service-based policies that are specific to whatever resources that we wish to use. Like, for instance, Internet Service Database, this device isn't licensed, so it's not going to be as accurate. But you can come through here and say, man, I use 8x8 from my phone. So I'll build a policy specific to 8x8 and allow it to go out to the internet. Meaning you no longer have to custom update all of those security profiles and whatnot. But ultimately, your goal here is to build out more specific policies that are relevant to your network above this catch-all so that you can eventually just disable little buddy. After you got your web policy built, your email policy and everything else, you can disable that catch-all and go, okay, what's not working? What's hitting policy 0 because it's not matching? Okay, well, damn, my email server or my multifunction printer all of a sudden can't scan out to Office 365. Well, let me build a policy for that real quick. And it gives you a safety net. You can re-enable this real quick, build out that more specific policy, make sure things are hitting it, and then do another test run, disable it. And that's basically how you tighten down the vice grip from a security perspective. Super, super sensitive, or super, super straightforward. The more you're in here, the more you're going to learn. This is a FortiWi-Fi, so I could stand up an SSID in tunnel mode, give it its own network, and then associate it with the inside policy or the inside zone, which means that you could then take that and run with it like you would anywhere else. We're not going to do that in this video. But yeah, this is a good start from a firewall perspective. Log settings. If you have a FortiGate in this day and age, FortiGate Cloud is free for 7 days. You can send your logs up there. It's not going to be as fast, but it's first in, first out, and it's roughly a 7-day retention. So you can do some rudimentary looking. I highly recommend a FortiAnalyzer or some level of third-party syslog, something like Splunk or QRadar or Logzilla, all the heavy hitters. That way you can send all your logs from your traffic. It'll make troubleshooting much easier. So that is the gist of configuring a FortiGate out of box to pass traffic and give you visibility on your network. This is a very simple deployment. This does not take into consideration an environment that would have multiple VLANs, multiple SSIDs, managed FortiSwitches, things like that. We will have very specific videos for those. This configuration is also a recommendation based on my experience, and it's assuming that this is not a critical environment. Obviously, if you are a big-time financial institution, medical institution, or military/government institution, you will not be as relaxed on your security policy as I mentioned in this video. But what this does is this will give you the ability to stand up a firewall relatively cleanly, relatively quickly, and get the visibility necessary to make the adjustments and the tweaks to help fine-tune things for you. Anyways, that's it. If you guys have very specific things about this video that you want to see expanded upon, please do me a favor. Put it in the comments below. I'm happy to help and expand. I want to try to make this as organic and as driven around you guys as possible. And like I said, if you haven't, do me a favor, like and subscribe, and then check out Packet Llama. We sell hardware. We're brand new though. Our website's not live, but the YouTube channel is. So go ahead and drop it a like as well. And until next time, I hope you guys have a wonderful week, a wonderful time. It's a couple days before Christmas here. So if this gets out before Christmas, Merry Christmas, Happy New Year. And I hope that you and yours are safe and happy.